Relations and functions. In the section Sets and Venn diagrams, we looked at relations in a very basic way. A relation is any set of points which connects two variables. Usually we'd be talking about x and y. As an example, just the set of coordinates, set A, where the coordinates are 1, -1, so 1 would be an x value and -1 a y value, and so on. This qualifies as a relation, as does the set B, which we can see here. We can graph these relations. So this is A, where we have 1, -1, 1, 1, 0, 0 at the origin there, 2, -4, and 2, 4. And here's B, 0, 0, 1, 2, 2, 4, 3, 6, and 4, 8. These are both examples where we have a finite set. In both cases, there are just 5 members of each set. We met some relations in sets and Venn diagrams. For example, the pair xy such that y is equal to -x. Or the pair xy which satisfy x squared plus y squared being equal to 9. This is a graph of the first of these relations, so this is y is -x. And here's a graph of the second one. X squared plus y squared equals 9 is a circle of radius 3 centered at the origin. Functions are a subset of relations. Therefore, not all relations are functions, but all functions are relations. They have the property that any single x value must give rise to only one y value. So this is for functions. They have to have this property that any single x value gives rise to only one y value. They can be identified using what's known as a vertical line test. So a vertical line test can be used to test whether a given relation is a function. If any vertical line drawn on the graph, and it has to be any vertical line, of a relation cuts the graph at most once, then the relation is a function. Now we'll look at this in operation. So let's consider the set A that we had before. We can spot that this is not a function because 1, -1 and 1, 1 indicate x value 1 gives rise to y values positive and -1. And we said back up here that a function would have the property that a single x value must give rise to only one y value. And here we can see that x value 1 actually gives rise to 2 y values. Likewise, x value 2 gives rise to y values positive and -2. Looking at this graphically, so here we have that set A again. And remember what we said about the vertical line test. Any vertical line drawn on the graph of a relation cuts the graph at most once. So it can cut it no times, it can cut it one time, but as soon as it cuts twice, it is not a function. So let's introduce this green line just here. And let's sweep it across the graph. And we can see at this point that the green line cuts the graph twice. Over here it didn't cut it at all, and that's okay. When it went through this point it cut it once, but here it cuts it twice, and therefore this relation fails the vertical line test. It's just a relation, it's not a function. On the other hand, this relation is a function. Here we can see that we're looking at the set B that we had before. And this is a plot of B. And we'll once again introduce the green line, which at the moment, when it's over here, cuts the graph 0 times. But as we sweep it across, we can see it never cuts more than once. It cuts once as it goes through each point, and 0 times in between. And that's fine. We only have a problem when it cuts twice or more. And of course this works with the infinite data sets as well. So we looked at 2, we looked at the set of points x, y such that y is equal to negative x. And that gives us the straight line that we know of as y equals negative x. If we introduce the green line again and sweep it across the diagram, we can see that it always cuts just once. So this particular relation is a function. But if we look at the circle, as we sweep across the circle, it's fine over here, it's not cutting the diagram at all. But as we sweep across, there are many points, an infinite number of points, where it cuts the graph twice. And therefore, the straight line here is a function, but the circle is just a relation that is not a function.